So now let's look at a question and then let's go through. So from the table below, we have to find I, the missing fractional abundance, percentage abundance, and mass number. So from the table, the fractional abundance is X to calculate for, the percentage abundance is Y, and then the mass number is Z. And then II, calculate the relative atomic mass of chlorine or Cl from this table below. So from the table below we have information, isotopes. So chlorine has two isotopes, one with a mass 37 and one with a mass one with a mass 35 and one with a mass 37. The atomic mass for the first one is 34.97. The atomic mass here is 36.96. Here the percentage abundance of the first chlorine is 75.77%, and then that of the second one we don't know. The mass number for the first one is 35. The mass number for the second one, they said we should write it, we don't know. And then the fractional abundance was not given for the first one. The second one was given as well. Now, let's look at the solution to this question. So, anytime we're talking about percentage abundance, let's take we have two isotopes, A and then B. Is that okay? If we express the different amounts of each isotope of A and then B in its naturally occurring element in the form of percentage, it means that the total abundance of this and this should be equal to 100. So when we add the abundance of A plus the abundance of B, if it's in the form of percentage, when we add the two, it should give us 100. Is that okay? If it is also expressed in fraction, when we add the abundance of A and then the abundance of B, it should be equal to 1. If it is percentage, when we add the abundance of each of the isotopes, the total should be 100. If it is fraction, the total should be 1. Is that okay? So now looking at the question we have here, we have two isotopes, chlorine 35 and then chlorine 37. The abundance for chlorine 35 was given at 75.77%. And then that of chlorine 37 we don't know, and that is why we should calculate for that value. How do we get this value? Since once we're talking about percentage in abundance, the total abundance of chlorine 35 and chlorine 37 should be equal to 100. So this was given as Y. So how, if we add this and this, we should get 100. This was given as 75.77, and then this one was given as Y. But the total of this is 100. How do we know the second one? That is by subtracting the one we know from 100. Is that okay? So therefore, Y will be equal to 100 minus 75.77. Is that okay? And what will be Y? Y will be equal to what? So we can use our calculator to punch. So we have 100 minus 75.77. And the answer is 24.23. 24.23%. So the value for Y here is going to be 24.23. So please, anytime the abundance is expressed in a form of percentage, anytime you add all the abundances in percentage, it should be equal to 100. So if you are given one and you're asked to find the other one, you just subtract it from 100. It will give you the remaining abundance of that isotope or atom in question. Is that okay? So now we know the value for Y. Y is 24.23. Is that okay? Now the second one is the mass number Z. So from our previous lesson on the structure of the atom, we said the superscript is represented by A, and then the subscript is represented by Z. The A indicates the mass number, and then the Z indicates the atomic or the proton number. So what is the mass number here? A is what? 37. So our Z here is 37. Same applies to the first one. Here is our A, and then here is our Z. Our A here is what? 35. That's why we have 35 over there as well. Is that okay? Now the last one is identify the fractional abundance. As I said, in percentage, if we add the two abundances together, if they are expressed in percentage, it can be 2 or more. Once you add them, it should be equal to 100. If it is fractional abundance, if you add the individual fractional abundances together, it should sum up to 1. So we are given 1 to be 0.2423. To know the other one, how do we do it? So we already know that if we add x, that is the fractional abundance for the first isotope, plus 0.2423, that's the abundance of the second isotope, it should be equal to 1. Anytime we are dealing with fractional abundance. So I know 1, and I'm asked to find the other one. How do I get the other one? That is by subtracting what I know from 1. Is that okay? So x, which is the fractional abundance for chlorine 35, will be equal to 1 minus 0.2423. And what is the answer? You can use your calculator to confirm your answer as well. 1 minus 0.2423. And that is 0.7577. And that is equal to 0.7577. Is that okay? That is how we can identify the percentage abundance or the fractional abundance if we know 1 and then we ask to find the remaining ones. Is that okay? If it is percentage abundance, the total should be 100. If it is fractional abundance, the total should be 1. Is that okay? Now let's move on to the second question. So in the second question, we have to calculate the relative atomic mass of Cl from the table below. So we can calculate the relative atomic mass of chlorine 1 using the abundance in terms of percentage or in terms of fraction. We are going to do for the two of them and then we will check our answers. So AR of Cl is equal to the summation of the mass. The mass of the first isotope times its abundance. Let's use the percentage one first. Plus the mass of the second isotope times its abundance. All divided by 100. So over here we are using percentage abundance. Is that okay? So the AR of Cl will then be equal to the mass, the atomic mass of the first one. So please, also the mass, we can use the atomic mass. If the atomic mass is not given and we are given the relative atomic mass of that isotope in question, we can use that, or they write the isotopic mass. If any of this is not given, you can equally use the mass number. So if this was not given, I can equally use the mass number of that atom. Is that okay? So the mass for the first one, since the atomic mass is given, let's use the atomic mass. So we have 34.97 multiplying the abundance of that one is 75.5. 75.77 all divided by 100. Is that okay? So once we get here, it is just mathematics and calculation. So we have, so this is the percentage, this is the information for the first one. Is that okay? Then plus the mass of the second one, we have here 36.96 multiplying its abundance. Its abundance is 24.23. Is that okay? All divided by the total abundance, or if it is in percentage, all divided by 100, or all divided by the total abundance. The total abundance is 75.77 plus 24.23, and that will surely give us 100. Is that okay? So you can just write all divided by 100, and then we are good to go. Is that okay? So you write information for the first one, and then information for the second one, all divided by 100. Once we get here, it is calculation. So we have 34.97 multiplying 75.77 plus the second one, 36.96 multiplying 24.23 all divided by 100. So we are going to get 35.45 5. That is if I approximate it to 2 places of decimal. So this is the AR of Cl, or the chlorine atom, if I'm using the percentage abundance for the calculation. So the relative atomic mass of an element involving isotope, it is just the mass of the first isotope. And I said the mass can be the atomic mass or the isotopic mass, or we can use the mass number. Is that okay? Times the abundance. The abundance can be in percentage or it can be in fraction. So here, the abundance here we are using is the percentage abundance. And these are the values for the percentage abundance. Is that okay? So once you're done with the first one, plus the mass of the second isotope times its abundance, all divided by the total abundance. If it is in percentage, you just divide by 100. Straightforward. Is that okay? The rest is mathematics and simple calculations. Is that okay? So the relative atomic mass is just the summation of the mass times the abundance of the individual isotopes in that element, all divided by their total abundance. So now let's also use the fractional abundance form. So AR of Cl is equal to the summation of the mass of the first one times the fractional abundance plus the mass of the second one times its fractional abundance, all divided by 1. Alright, so the mass of the first one is 34.97 times the fractional abundance. So the fractional abundance over here was 0.7577 per our calculation at the initial stage. So multiplied by 0.7577. This for the first one plus the mass of the second one, 36.96, multiplied by the abundance. The abundance over there is 0.2423. Please, that is the fractional abundance. We are using the fractional abundance method, all divided by 1. So the summation of the multiplication of all these, you just assist yourself with a calculator, or you can use your mind to do the calculations as well. So we have 34.97 multiplying 0.7577 plus 36.96 multiplying 0.2423. All these divided by 1 because we are talking about fraction. And our answer is 35.45 if I approximate it to 2 places of decimal. Is that okay? Which is approximately 35.5. Same applies to this one, 35.5. So the relative atomic mass of chlorine is 35.5. Is that okay? Please. So anytime you calculate the relative atomic mass of an element, it is just the summation of the mass of the individual isotope times the abundance, all divided by the total abundance. So we've calculated it using the percentage abundance and also using the fractional abundance. Is that okay? Now let's take another question.